Hello and welcome to example 12. In this example, the area of a region is defined by the inequalities y smaller than or equals to 2 minus 2x squared and y bigger than or equals to 2 minus 2x. Now, the less than or equal sign for the first inequality tells us that the region required has y coordinates less than 2 minus 2x squared. In other words, is the region below the graph. For the second inequality, the more than or equal to sign tells us that the region required is the region above the graph of y equals to 2 minus 2x. With this understanding, let's find the volume formed when the region is rotated through 4 right angles about the x-axis. When we consider the requirement of these two inequalities, we will understand that it has to be above the straight line graph and yet below the curve. So it must be this region that I've shaded in blue. So for part 1, when we revolve the shaded region about the x-axis, what kind of solid do we get? Let's take a look. Now in this diagram, the region required by the question is the region in green inside this diagram. And when we revolve the region in green, we will get this red color shell-like structure. Can you see that there's a hole in the middle? It's like an empty bowl. So it's like a shell. How do we calculate the volume of this solid of revolution? Now, if we look at this diagram here, we will see that if we rotate this shaded green region about the x-axis, we will see that we get something that is a whole solid without any hollow in the middle. So what's the difference? The difference is over here, we are not rotating the region covered by the orange triangle. So let's see, what do we get when we revolve the region covered by the orange triangle? From earlier lectures, we know that we're supposed to get a cone. So let's see here. Yes, we can see that we indeed get a cone. And this is the cone that makes the difference between our required solid and the one with no hollow in the middle. Now, from this few animation, I hope you can see that when I get back to the question, I hope you can see that the volume that we need to calculate, which needs to be the volume generated by the area that I'm highlighting in red now. This subtract away the volume that is generated by the triangle in the middle. Means whatever I highlight in green. So firstly, the volume generated by this whole region here that I've shaded. This region is bounded by the curve y equals to 2 minus 2x squared and the x-axis. We know from earlier lecture that the volume generated will be equals to integration of pi y squared dx, where the value of x is from 0 to 1. Now we substitute in y equals to 2 minus 2x squared, and we will end up with the integral over here that I boxed out in blue. We know that this is the solid without any hollow in the middle that we have seen in our animation. So from this solid, we need to subtract the volume generated by the triangle, volume generated by revolving this triangle in the x-axis, which means that it gives us the cone. So we must subtract away the volume of this cone. For this cone, the height equals to 1. The radius of the cone is over here. Radius equals to 2. So for cone, we know the volume is 1/3 pi r square h, and that gives us the volume that I'm boxing out in red now. So the bigger volume in blue, subtract away the smaller volume in red. Upon simplification, it gives us the final answer 4 pi over 5. Thank you for watching this video.